Okay, before moving on to the next slide, I wanted to mention one more thing. A lot of people figure out, and it's just kind of an easy way to know your unit circle values, that when you're talking about the sine and the cosine of a specific angle, if you happen to know the ordered pairs or those point values on the outside of the unit circle, a lot of people tend to figure out that the sine value goes with the y value of the ordered pair, and the cosine value goes with the x value. So typically, your cosine value is your x value, and your sine value is your y value. Again, that works with the unit circle specifically. All right, let's move on to a full circle and just kind of see how everything relates. So again, if we happen to already know the information in the first quadrant, the nice thing is, like, let's just say we're going to take this one for example right here. That ordered pair right there is the square root of 3 over 2, 1/2. Everything in the unit circle is based upon symmetry when it comes to this, which should ultimately make sense because that square root of 3 is the distance in the x direction. And then that 1/2, kind of missed, is the distance in the y direction. So now let's think about it. What if we went in the opposite direction? Again, it's all based upon symmetry here. The distance in the x direction, well, it's the same distance that we covered, but in the negative direction. And it should also make sense. We're going to the left, so the x value there is going to be negative. And then if we go up, well, it's exactly the same y value because we went in a positive y direction. So the ordered pair over here is identical to the one that's across from it, except that the x value is negative and the y value, excuse me, is still positive. It's the same thing. And then if you want to think about it as being symmetric across the x-axis as well, it works the same way. So again, going to the right first, the x direction hasn't changed, but then coming down here, the y direction now is negative. So this ordered pair is going to be a positive square root of 3 over 2, but a negative 1/2 because the y value was negative. And then in your third quadrant, going out here and then down here, x and y are both negative, which should make sense that you have a negative square root of 3 over 2 and negative 1/2. Okay, so why is that important? Well, because if I happen to know what this angle is right here, which is pi over 6, if I know what the angle is over here, I can then very easily figure out what the sine and cosine of that angle is because I know it's going to be symmetric to the pi sixth angle. And when we went through kind of reviewing all the different angles, I specifically went through not reducing the angles at first, but then going back and reducing them when we could. The reason I do that is because when you are dealing with the symmetry, you are going to be dealing with what I call all of the non-reducible angles. Every angle that we have that is symmetric to pi sixth is going to be a non-reducible something pi over 6. For example, if I wanted to say 3 pi over 6, we know that 3 over 6 reduces to 1/2. That is not considered non-reducible. So if you start counting your pi sixth, 1 pi over 6, 1 pi over 6 doesn't reduce, which is the first one that we already have there. 2 pi over 6, well, 2 over 6 reduces. 3 pi over 6, that reduces. 4 over 6, that reduces. 5 pi over 6 is the next non-reducible pi sixth, which tells me that this angle over here is 5 pi over 6. And that would be the angle that goes all the way from here, all the way around, erase that, goes from here all the way around to there. That is 5 pi over 6. Okay, the next one would be 6 pi over 6. Well, that's reducible. That makes sense because that's at the same place as pi. So the next one is 7 pi over 6. So this one right here represents 7 pi over 6. 8 pi over 6, 9 pi over 6, 10 pi over 6, all of those reduce. The last non-reducible is 11 pi over 6, which is all the way around. I kind of do another one all the way around to there. That's 11 pi over 6. Okay, again, why is this important? So if I know that sine of pi over 6 is 1/2, I've chosen to just memorize that, it's easier. Then I also know that the sine of 5, oops, not s of, sine of 5 pi over 6, sine of 7 pi over 6, and sine of 11 pi over 6 are also going to be 1/2. The biggest thing I have to know is, are they positive or negative based upon where the quadrant is? Well, again, if you remember that sine basically is associated with y, anything above the x-axis will give you a positive value. So sine of 5 pi over 6, because that is above the x-axis, is also positive. Where sine of 7 pi over 6 and 11 pi over 6, basically in quadrants 3 and 4, are below the x-axis, those would give you negative values. So it's a good way to just kind of equate where is my angle. So that's the biggest thing you'll have to be able to figure out. So if I just ask you randomly, what is the sine of 7 pi over 6? The first thing you need to figure out is, okay, well, what quadrant is that in? Well, that's in the third quadrant because 7 pi over 6 is just a little bit bigger than 1 pi, which is the horizontal to the left. Excuse me. And that'll put it into the third quadrant, which means it is below the x-axis. So it's the same thing as sine of pi over 6, but negative. All right, so that really should help trying to fill out all these things on the circle. I am not going to go through every single value on the circle here. That is something that you guys can do on your own, but that's the general concept. So let's just do one off the top. Now let's just say I wanted to find the cosine of 4 pi thirds. First thing you have to figure out is, where the heck is 4 pi thirds? Well, again, it is all the non-reducible pi thirds. Pi thirds would be here at this one. Okay, that's not an ordered pair, that's just the angle. 2 pi thirds, well, would be the next one. That's non-reducible. That's over here. 3 pi thirds, well, that's pi. So that's reducible. And then 4 pi thirds is here. But once again, look at the symmetry. 60 degrees away, or pi thirds. 60 degrees away, or pi thirds. 60 degrees away, or pi thirds. And the next one would be 60 degrees away, or pi thirds. It's symmetric. And that one actually would be 5 pi thirds. So to figure out cosine of 4 pi thirds, I really want to know what cosine of pi thirds is, and then figure out, okay, this thing's in the third quadrant, so I know if it's positive or negative. So cosine of 4 pi thirds is going to be the same thing as cosine of pi thirds. Well, here's where my thought process comes in. Sine of pi 6 was 1/2, which means that cosine of pi 6 has to be square root of 3 over 2. So if cosine of pi 6 is square root of 3 over 2, that means cosine of pi thirds has to be the other one, which is 1/2. And the fact that this is in the third quadrant means that x and y are both negative, so that is negative 1/2. Okay, I know I kind of ran through that thought process pretty quickly. Ultimately, whatever thought processes that you come up with that'll help you to figure those things out, that's what you need to do. All of this stuff is going to be helpful when it comes to reference angles, which is what we're going to talk about in the next and our last video for the day. And reference angles basically are a way of saying, okay, I'm giving you an angle. I want to know what its first quadrant equivalency would be, or how many degrees away from the positive or negative x-axis would it be. That's what we're going to be talking about in our third video.